Okay, a store manager gathers some demographic information from the store's customers. The following chart summarizes the age-related information they collected. So we have here, seems like the random variable is age collected there, and here we have the frequency. We could find the relative frequencies if we knew the total. All we had to do is add up all these numbers, and then each of the relative frequency would be the given frequency divided by that sum. So this is not given as a probability distribution, but it would be relatively easy to change it by finding the relative frequencies. So let's go ahead and answer these questions. It says one customer is chosen at random for a prize giveaway. Round answers to 4 decimal places. Part A. What is the probability that the customer is at least 20 but no older than 39? So what is the probability that the customer is at least 20? So that's everybody who is 20 and over. That's pretty much everybody down here, but no older than 39. So that stops actually right there. I'm only looking for those 2 classes. So if I'm talking about people who are older than 20 but younger than no older than 39, I'm only looking for those 2 classes. And those 2 classes amount to 87 plus 60, 147. So the probability that the person's age, which I'm going to call X, is less than or equal to 40, but greater than or equal to 20, is equal to the number of people that fit that criteria, which is 60 plus 87 over the grand total. And when you add all these up, you get 439. So if you add all of these things up, the grand total is 439 for all of them. So of the 439, it's 147 of them that actually are in that age range, so that the probability of getting somebody in that age range is roughly 0.3349 when rounded to 4 decimal places. So that's the answer for the first part here. 0.3349 is the probability someone's between 20 and 39. All right, so next we're looking at that second one, part B, and it's asking for the probability that a customer is either older than 60 or younger than 40. So that's the probability that X is greater than or equal to 60, that's older than 60, or X is less than or equal to 40. So we're looking for that probability. The OR rule says that if the events are disjoint, if they can't be occur at the same time, then I can just add their probabilities together. And you can't, one person can't be both over 60 and under 40. So these 2 events are mutually exclusive. So all I have to do to find the probability is add the probability of being greater than or equal to 60. I have to add to that the probability of being less than or equal to 40, that one of these customers is less than or equal to 40. So let's see. The probability that the customer is greater than or equal to 60, well, that would be these 92 people who are greater than or equal to 60 in age. And the probability that X is less than or equal to 40 would be pretty much beginning here. The 60 plus 87 plus 59. So one of them is going to be 92 over the grand total of 439. That's the probability of being over 60, because there's 92 of the people who are over 60 in this sample. And then I'm adding to that the probability of being less than or equal to 40. Well, the people who are less than or equal to 40, that's 60, these 60, plus 87, these 87, plus 59, that 59, all over the grand total of 439. All right, when all these get added up, it amounts to 298 on top over the 439 on the bottom because they already have common denominators. So when you add all this up, you get 298 over 439. And when you do that arithmetic, when you do divide that, you get 0.6788, or roughly 68%. 88. Okay, and the last one, what is the probability that the customer that was randomly selected is at least 50? At least 50 means 50 or more. So at least 50, let me see. Here's where 50 begins. So to be in this category, you have to be at least 50, but we also want everybody above that too. So we're talking about that 64 and that 92. 64 plus the 92. So the probability of being greater than or equal to 50 in age is equal to those two. The probability of being in either this row or this row, those two rows, which are 64 plus 92 people out of the total of 439 people. Well, that's 156 out of 439, which is approximately equal to 0.3554. So that's the answer for the last part, 0.3554.